And now let's talk about adding and subtracting powers with numerical basis. Right, so firstly, there are several things that I want you to remember when it comes to this. Number one is that whenever you are adding or subtracting exponents, right? So the first thing that you're going to have to remember is applying factorization. Okay, now factorization. Now I need to give you a warning that for you to factorize, in this case, powers or expressions that have exponents in them, firstly, the base has to be the same as well as the exponent as well for them to be common factors, right? So you factorize by removing common factors, right? So let me just say remove common factors. Okay, so you remove highest common factor. Okay, remember, for it to be a highest common factor, bases have to be the same as well as exponent need to be the same. Okay, right, very important for us to note that. In fact, whilst I'm at it, let me just talk about it quickly. So if I've got something like 2x plus 1 multiplied by 3, okay, 3 into the exponent of 2x, okay, I'm really trying to erase this, times 2x, okay. Now, if I look at this, it might look like, all right, there's a whole lot that's going on there. In fact, let me put a plus sign in between, okay, for me to be able to factorize. All right, now, I want you to note this. Firstly, what do we have? On the first one, I can actually rewrite this as 2x multiplied by 2 to the power of 1, okay, plus 3 multiplied by 2 to the exponent, or to the power of 2x, to the power of x rather. Now, I want you to note this. I've got, in this case, similar powers. The base is the same, and so is the exponent. Okay? Now, what is the highest common factor in this case? Well, it's exactly 2x. Now, if I were to take 2x out as a common factor using factorization, what am I left with in the first term? I'm left with 2. And on the second term, what am I left with? I'm left with 3. And please don't forget to put that sign there, that plus sign. So in actual fact, this works out to becoming 2 to the power x multiplied by 5. I hope you can see that, ladies and gents, right? So please remember, when we are factorizing, we remember, in this case, the basis must be the same, the exponents must be the same too. I'm going to apply some more of this as we go along. But what's the second thing that I want you guys to actually remember? Remember that whenever we are factorizing, sometimes we'll have to look at the difference of two squares. Okay? Now, for you that are in grade 11, please, I want you to remember this. Okay? So whenever I've got any expression, let's say I've got x squared minus 4. Now notice, both of these are actually perfect squares, right? And them being perfect squares, there's a minus sign in between. So therefore, we refer to them as the difference of two squares. So notice, whenever I factorize the difference of two squares, right, I will take the square root of each number. So the square root of x squared is x, right? On each bracket, I'm going to write the square root of each number. So the square root of x squared is x. The square root of 4 is 2, right? Remember, 2 times 2 gives me 4. So in this case, all I simply do is just write down different signs inside. So this is how you factorize the difference of two squares. So what am I saying in this case? There are going to be instances where we are going to have to deal with the difference of two squares. So for instance, if I have got 3 to the power of 2x, let's say minus 9. Okay, right, if you look at this, this is a perfect square, but so is this. Okay, now how would I factorize this? So I can actually write this as 3 to the power of x, right? That's the square root, plus 3. And I can also have 3 to the power of x minus 3. Remember, 3 to the power 2x can actually is the same as 3 to the power x multiplied by 3 to the power x. So in this case, it is definitely a perfect square. So this is how we would actually factorize something like that. Please keep that in mind so that you're able to identify it as quickly as possible. Right, I'm going to actually do the other types of examples perhaps a little bit on the next video, okay? But remember also that we can use K-method substitution. I won't talk about it in this video, but we will do that in the next video. Right, so this is how we're going to factorize. And I want us to go to the very first example that we are going to have. So suppose we've got 3x plus 1 minus 4 times 3x minus 1. So note we've got addition and subtraction. That's the difference from the multiplication and the division in this case. So divided by 3x minus 2. Now, how are we going to solve this? Right, so we said the first thing is you need to ensure that you take out a common factor. Sometimes it's not as easy to identify. So firstly, try to actually just simplify it as much as possible. So 3x times 3 to the power of 1, right? Minus 4 times, we've got 3 to the power x times 3 to the power of minus 1. All right, and this is divided by, you can write this as 3 to the power of x times 3 to the power of negative 2. Now, in this case, do we have common factors? Right, so the highest common factor that I have at the numerator is 3 to the power of x. Right, so I can take that out as a common factor. In my first term, what am I left with? I'm left with 3 to the power of 1 minus, right, so I'm left with 4 times 3 to the power of minus 1. Remember, this can be written as 3 to the power minus 1 can be written as 1 over 3, right? 1 over 3 to the power of 1. So now, let's quickly have a look at it. All right, so we now at the bottom have 3 to the power of x times 3 to the power of negative 2. If you want to, we can actually write this as 1 over 3 squared. Okay, we'll do that later. But first of all, right, we've got common factors in this case. So we've got something that is common in the numerator as well as the denominator. So what we do is that we can cancel it out. Note in this case that we've got multiplication signs in between the two. So as a result, we can cancel that out. Okay, now what are we left with? We are left with 3 minus 4 over 3. Okay, 4 over 1 times 1 over 3. That will give us 4 over 3 divided by, right, we've got 3 squared, which in this case, 3 to the power minus 2 rather, which can be written as 1 over 3 squared, and 3 squared is 9. Okay, right, now ladies and gents, you can make this simpler for yourself. You can put this in the calculator, but I want us to learn to also just do this in this case in the simplest way possible. Right, so you've got 1 over 9 in the denominator, so multiply by the inverse, which is 9 over 1. But now because you are introducing something that wasn't there before, right, multiply by 9 over 1 but what I do at the bottom, I need to do at the top so that it doesn't change anything, right? So I've got 9 and 9 cancel out. Okay, 9 over 1 times 3 gives me 27. Okay, and 9 times 4 over 3 in this case. So remember, 9 divided by 3 would give me 3, and multiply that by 4. So that would be 9 times 4 over 3. Actually, let me write it out. This is the same as saying 3 times 3 multiplied by 4 over 3. So the 3's cancel, and 4 times 3 gives me 12. So you've got 27 minus 12, and in this case, that will give us 15. All right, and that is how you'd get to the final answer. But in this case, if you found this a little bit challenging, of course, you can always just put that in your calculator. You should be able to get an answer. However, I do insist, ladies and gents, you must be able to deal with fractions. Right, let's go on to the next question. Right, so what happens in this case? Let's say you've got, okay, let's have 4 to the power of x plus 2x plus 1. Okay, in fact, let's say 2 to the power 2x minus 1 divided by 2 to the 2x, okay, minus 1 again. Right, so we've got a plus sign in between. Please note in this case, we cannot simply just apply the multiplication laws. We need to be cognizant of the fact that we've got that plus sign. Okay, so we've got, right, we need to change numbers into prime factors again. So that becomes 2 squared, okay, raised to the power of x, plus we've got 2 to the power 2x multiplied by 2 to the minus 1 divided by, let's do the same at the denominator, it's 2 to the power 2x times 2 to the power minus 1. So what happens in this case? Well, we've got 2, if we apply our rules, okay, our laws, so that becomes 2 to the power 2x plus, we've got 2 to the power 2x times 2 to the power of minus 1 divided by 2 to the power of 2x times 2 to the power of negative 1. Right, again, ladies and gents, if you look at the numerator, we've got a common factor, right? The highest common factor there is 2 to the power of 2x. And if I take that out, in my first term, right, of course, this is 1 times 2 to the power 2x. So I'm left with a 1 there. Please don't be alarmed where that comes from, right? Okay, that's plus. That plus there. We've got 2 to the power 1 minus 1. So we can write this as 1 over 2 to the power of 1, right? And we've got 2 to the 2x again, multiplied by 1 over 2 again. So those two cancel out. And what are we left with? We've got 1 plus 1 over 2, which will give us 3 over 2, divided by 1 over 2. And ladies and gents, if our denominators are the same, so now we can just simply cancel them out, and we can just divide the numerators. 3 divided by 1 would give me 3. Right, I hope that makes sense, ladies and gents. Right, I want us to take just one last example. I want you to try it out on your own and see if you can get to some kind of a good answer. Right, so let's take that. Let's say we've got 3 to the x plus 2 minus 3x divided by all right, please try it out first and then look at my solution after, right? And as I said, in our next video, we are going to be looking at, just factorizing those using the K method substitution, but as well as we are going to look at, just making sure that we can factorize, in this case, the difference of two squares as well. All right, let's quickly have a look at the solution. Hopefully you've paused, you've tried it out on your own, okay? And let's see, what would the solution be? We will have 3x times 3 to the power of 2 minus 3 to the power of x divided by, we've got 3 to the power of x times 3 to the power of 1 minus 3 to the power of x times 3 to the power of negative 2. All right, so again, do we have any common factors? Highest common factor? Absolutely. So 3 to the power of x, right? So what are we left with in the first term? That's 3 squared minus 1. Okay, divided by, again, 3 to the power of x. We've got 3 minus, okay, I was sneezing there a little bit. So that's going to be 3 to the minus 2. That's going to give us 3 to the power of minus 2. We'll deal with that a little bit just now. So, which means those two can cancel. Right, so now we've got 3 squared minus 1. Okay, so 3 squared is 9 minus 1. That gives us 8 divided by, so we've got 3 minus, now remember 3 to the minus 2 can simply be written as 1 over 3 squared, which is 1 over 9. So that will give us 8 divided by 3 minus 1 over 9. Now, ladies and gents, if you're struggling just a little bit with this, of course, you are more than welcome to use your calculators for now, but let us try to actually solve for fractions together. I want you to get used to it. So if you look at this, we've got our LCD in the denominator. We've got 9 there, right? So what you can actually do is that you can multiply by 9, but what you do at the bottom, you can actually do at the top, okay? So let's do this. So that would be 9 times 8. In this case, that would be 72. Okay. All right. So that's divided by, okay, so that's 72. And at the bottom, you've got 9 times 3, which is 27. Okay, minus 1. And so that would give us 72 divided by 26. Okay. And of course, you can try to simplify this as much as you possibly can. All right. And I think what we can do is that these are both factors of, we can actually just try to simplify it as much as possible. And you'll be left with 36 over 13. All right. So that is how the cookie crumbles. Ladies and gents, I want to leave it here. As I said to you, I want you every single time that you take these sort of examples, try to do as much as possible on your own so that you can flex your muscles a little bit. But as I said, in our next video, we're going to be looking at using the K method substitution or also the perfect square. For now, ladies and gents, I am going to leave it here. From me to you, it's sharp sharp.